Hi everyone, we're Team CPM10, and we've spent the summer exploring how generative AI might be able to help students read and make sense of academic research papers. My name is Evan Ujwak. I'm from Nashville, Tennessee, and I go to school at Rutherford County Virtual School.
Hello, I'm Tim Zhang. I'm from Shenzhen, China, and I'm currently studying in Shenzhen Middle School.
Hello, I'm Hassan Zubair. I'm from Dhaka, Bangladesh, and I'm a senior at Nerd.
And I'm Kitty from Shanghai YK School, and our mentor is David Torres Mendoza. So what this project is about and why we did it. So this project was inspired by real needs in CMPM 15, a research exploration course where students read and discuss papers in small groups. Many struggles with the dense technical language or lack experience knowing where to start. This can leave them feeling lost, nervous to join the discussions, and even discourage them pursuing research. So this leads us to our research question. We wanted to know, can AI scaffold the reading process in a way that supports but not replaces student thinking?
Research papers aren't meant to be read like stories. They jump around, use dense technical terms, and can be hard to follow, especially outside your field. You have to pause and think about how the authors build their argument, which is where many students struggle. GenAI tools like ChatGPT can help, but often make things up, oversimplify, and don't prompt reflection or self-checking. And that's why this research question of ours matters. If AI just gives answers, students may feel confident without truly understanding. Teachers can't support everyone individually, and most students don't know how researchers actually read papers. But AI that guides reflection, asks good questions, and keeps students engaged can make research reading more accessible. Our goal wasn't to make an AI that just summarizes the key ideas for you. We wanted it to scaffold learning to support students step by step while they do the thinking. We also wanted to ground everything in real reading strategies so that our AI was acting like a truly collaborative teacher. We aim to design prompts that would keep the focus on reflection and tested different tools and prompt styles to see what actually worked for students.
So before I go over our approach this summer, I want to mention the two tools we used. We used Google's Notebook LM platform and an open source project called OpenWebUI. We'll go into more detail about both in just a moment. So this summer, we started with a literature review on metacognitive learning theory. Then learned the Notebook LM's capabilities. We studied common reading strategies to ground our prompts, experimented with Notebook LM, and iterated on system prompts. We moved on to OpenWebUI for deeper customization, evaluated individual prompts, and then combined the best ideas as a team. And finally, we refined them into our final system prompt for the first of the three reading stages. So the first tool we used was Notebook LM from Google, an AI-powered note-taking and research assistant. It's source-based, meaning it mainly used uploaded sources for responses, making it less likely to make things up than general chatbots like ChatGPT. Here's the general overview of the interface. So on the left side are our uploaded sources, which the AI uses when responding. We found these can also shape its tone and behavior, like a system prompt. For example, uploading the system prompt saying that speaking like a pirate makes the AI respond like a pirate. The middle chat interface lets the user ask questions and get answers and feedback. Since the Notebook LM is source-based, it includes citations showing exactly where the answer came from. Next is the Studio section on the right side of the interface, which has several tools of supporting understanding and synthesis, including study guides, briefing docs, FAQs, timeline, and mind map, and the audio overview. One of the more interesting tools in the studio interface are the audio overview. Here's a quick example of one.
Welcome to the deep dive. We're here to unpack some complex, high-stakes topics, trying to pull out those key bits of knowledge.
Great to be here.
Today we're looking at something really cutting edge. Intelligent automation, but for network defense.
Yeah.
Like, what if AI could just defend our networks all by itself?
So audio overviews are short AI-generated conversations between two hosts that summarize the source, like a podcast. They're great for great understanding. They're great for quick understanding while multitasking, and you can customize the tone and style to fit with different learning preferences. So overall, testing showed that the chatbot struggles with our method, gives long answers, and show confirmation bias. The study got an FAQ, help with reflection, but assumes the user's prior knowledge. While the briefing doc is detailed, yet vague and overthinks for the user. The timeline wasn't helpful, the mind map is shallow, and the audio overview adds filler content and exaggerates some of the details. Overall, the Notebook LM works best for someone who has already read the paper and wants to explore it deeply or connect it to other sources.
After Notebook LM, we move to OpenAI, an open source interface for building and running LM chatbots without coding. It lets you create custom chatbots with your own system prompts, connect models like OpenAI's Foro Video or Google's Gemini Plus 2.5, and add those for tasks like search story text. Its big advantage is how easily you experiment prompts and sometimes the same but sometimes testing line for more objective evaluation. Here is an example of its interface for setting up a model without hiding. Using the same system prompt in both tools, OpenAI followed instructions better, kept the answers concise, and avoided speaking for things. Notebook LM often broke rules, giving too much detail early, like movie spoilers when you have only seen the trailer. Notebook LM works for quick summaries, but OpenAI work for system prompts. Setting the model's role and behavior from the start made it better choice for our step-by-step reflecting reading process.
Before we started designing our prompt, we wanted to figure out how the AI should guide someone through a paper. We didn't want to just make it up ourselves. So we looked at established reading strategies used by researchers and educators. We focus on three: Koch's three-pass method, the SQ4 method, and the KonMari method. Each one approaches reading in a different way, and together they give us a strong foundation for our design. Koch's three-pass method reads a paper in layers. The first pass skims the title, abstract, headings, and conclusion for the big picture. The second pass goes deeper, focusing on figures and diagrams without getting stuck on every detail. The third pass is the in-depth, taking notes, challenging assumptions, and aiming to implement the research. Next was the SQ4 method. This is all about turning readings into an active process. First, you survey the paper to get an overview. Then question. Write down questions about what you expect or want to find. Read to try to answer those questions. If you're still stuck, respond by reading further until things click. Next, record what you've learned in your own words. Finally, review the material regularly so it sticks. The KonMari method is a checklist for understanding a paper. Question, alternatives, which is also called hypothesis, logic, or why it makes sense, method, result, and inferences, asking for broader implication. It links the paper starting point to its takeaway and pushes you to consider why the research matters and how it fits into the field. We combine elements from each method. Koch's three-pass method gave us the structure to design prompts for each stage. SQ4 inspired constant engagement, with the AI asking questions and nudging readers to explain their thinking. Comrie added a focus on linking the paper's idea to the bigger picture. Together, these create a prompt with structure, engagement, and critical reflection.
We've mentioned prompt engineering a few times, but what is it? It's designing and refining instructions to get specific kinds of responses from an AI. Most of our work was creating and tweaking prompts so that the AI could guide readers in the way that we wanted it to. Prompt engineering is super important because it shapes the AI's responses, making them more accurate, relevant, and in the tone or style we need. This is especially useful for complex or specialized tasks where generic answers won't cut it, like trying to be a reading tutor. In our project, most of our time went into testing strategies like zero shot, few shot, and role prompting to make sure the AI guided readers step by step, stayed engaged, and matched our design goals. Our goal was to design a system prompt that could guide a student through reading, interpreting, and analyzing research papers with a user-first focus. We wanted it to be clear, accessible, and to build a deeper understanding. Our methodology was iterative. Each of us applied a different prompt engineering techniques we learned, tested our prompts, shared what worked, and refined them based on feedback and performance. We kept evaluating against the same criteria: clarity, helpfulness, and whether it encouraged critical thinking.
We began with individual prompts, testing and refining them whenever the prompt model is trained. We paired up choosing the strongest parts in group of models, tested them, and improved on weaknesses. In the final stage, we created hybrid prompts from both group models plus mentor input and used OpenWeb UI's evaluation tool to test 5 paid LLMs, selecting the best for our final implementation.
This annotated version highlights some of the prompt engineering strategies we used. You can see the role prompting at the top, the system/contextual prompting in the opening paragraph, the role-guided questioning in the numbered list, and the constraints in the instruction section. Almost every part of the prompt is there to shape the AI's behavior so that it supports but doesn't replace the student's own thinking.
We evaluated prompts using OpenWeb UI's arena-style setup, where two random models responded to the same user message. Trying to create them, we picked a better response, rated it, and gave feedback. We repeated this across full reading sessions with several papers. The Group SK model performed best with Group PE close behind. So we used Group SK as our base and parsed strong elements from Group PE to the final prompt. Once we had our final system prompt, our last step was figuring out which LLM ran it best. We tested 5 paid models in another blind arena-style setup using the same evaluation method described earlier. After multiple rounds, DeepSeek D3034 consistently came out on top, so that's the model we locked in for our chatbot. Here is our prompt in action in Scheme Pilot. The chatbot guides reflective reading while the app blurs sections you can skip, keeping focus on what matters and reducing cognitive load. Our work this summer, designing, testing, and refining the system prompt, is one part of Scheme Pilot's larger goal to combine interactive guidance, visual aids, and AI coaching to help students engage deeply with academic.
If we had more time, here are some things we tackle next. First, we test the prompt on a wider range of papers and user backgrounds, designing prompts for passes 2 and 3 of Keshav's method, and add tone/style customizations so users could adjust formality without changing the core system prompt.
So what we learned this summer? This project helped me to get the idea of using LLMs effectively and properly. LLMs can increase our metacognition skills if we know how to use them properly. Nowadays, the most common practice of LLMs is getting direct answers or responses that take very less time, but doesn't really help with better understanding.
So in this research project, I learned that iteration and continuous evaluation is a very essential part. So through iterations and modifications with system prompts, we recognize that certain features in the system prompts may help the model to better comply the prompt, such as making the prompt more chronological, structuring it as steps, and also adding markup signs next to important instructions. Therefore, a successful prompt may lead to more successful responses.
Something I've learned from this project is that there is always a mutually reinforcing relationship between the users and the GenAI tools. If one can better understand what they are weak at, they will in turn improve the prompt creation based on their needs. Conversely, once a better prompt is created, one can better understand the research paper with the help of it.
Something I learned from this project is that when designing system prompts, it's important to execute the intended function. This can only come from being direct and explicit in construction. It takes time, a mix of iteration, testing, and problem solving, but by blending together communication and logic, you can achieve the model behavior. Thank you all for taking the time to watch our presentation. Thank you to the SIP organizers for their support and to everyone who helped accommodate virtual interns as well as family and friends. Also, a special thanks to our mentor, David Torres Mendoza, for furthering our development as young researchers.